Here we have pre-calculus problem. Okay, let's go with the information. Your roofing contractor purchases a single delivery truck with a single elevator for $39,000. The vehicle requires an average expenditure of $5.50 per hour for fuel and maintenance, and the operator is paid $11.50 per hour. Okay, here we have 4 questions. So the first question is, write a linear equation giving the total cost C of operating this equipment for T hours into the purchase cost of the equipment. Okay, now let's answer part A. So to get the total cost C of T, what we have to do is we have to add the fixed cost and variable cost. In this case, the fixed cost is the purchasing cost of the truck, that is $39,000. So let me write it over here. So $39,000 is the fixed cost. Okay, variable cost is the money spent each hour. So it is given in 2 categories. The first category is for fuel and maintenance, and the second category is so the salary paid for operator. So in the first category, $5.50 per hour is spent for fuel and maintenance. In the second category, so operator is paid $11.50 per hour. So to find the variable cost per hour, we have to add these 2 values. When I add 5.50 and 11.50, I am getting $17. So the variable cost is $17 per hour. But we have to find the variable cost for T hours according to the information we have in part A. So to find the total variable cost for T hours, what I have to do is I have to multiply the variable cost for 1 hour and the number of hours, that is T. So when I multiply 17 and T, I am getting 17 T. So this is the total variable cost for operating the truck for T hours. So this is fixed cost and this is the variable cost for T hours. So this linear equation gives the total cost C of operating this equipment. Okay, now we have finished answering part A. Okay, now let's answer part B. So let me go over the information we have in part B. Assuming that customers are charged $30 per hour for machine use, write an equation for the revenue or derived from T hours of use. So for 1 hour of using machine, the customers are charged $30. Then how much money will be charged from the customers for T hours of use? So for that we have to multiply the cost for 1 hour and the number of hours, that is T. So then I'm getting R of T equals to 30 times T. So this is the revenue we are getting for T hours of the using machine. Okay, now let's do part C. Okay, let me go over the information in part C. Use a formula for profit, that is P equals to R negative C, to write an equation for the profit derived from T hours of use. Okay, so here in part C we have the formula to get the profit. The profit is equal to revenue negative cost. So whenever we subtract the cost from the revenue, we'll be getting the profit. So P of T equals to, let's already we got the stuff that is equal to revenue, that is 30T. We have 30T negative, and already we got the stuff for that is for cost, that is 39,000 positive 17T. Let's write this one in parenthesis, 39,000 positive 17T. Okay, now let's do some simplification over here. 30T. Now we can distribute this negative sign to this and this. I'm getting negative 39,000 negative 17T. So then we get P of T equals to, we can combine this 30T and negative 17T. So when I combine them, I am getting positive 13T negative 39,000. Okay, now I got the result for part C. So this is the equation we have for profit, that is P of T. Okay, now let's answer part D. Use the result of part C to find the break-even point. That is, the number of hours this equipment must be used to yield a profit of $0. Actually, break-even point is nothing but the point at where the revenue and cost are equal. In other words, we can say the profit is equal to 0. Okay, already we got the profit, the expression which represents the profit in part C. So, like to get the break-even point, always the profit has to be equated to 0. That is, P of T has to be equated to 0. Okay, so for P of T, we have the expression that is 13T negative 39,000 equals to 0. Okay, now let's solve for T in this one. For that, we have to add 39,000 to both sides. When I do so, I'm getting 13T equals to 39,000. Now to solve for T, I divide both sides by 13. This 13 and 13 will cancel out. 13 goes into 13 one times and 13 goes into 39 3 times, and we have 30 over here. So I am getting T equals to 3,000. So if I want the profit has to be 0, then the equipment must be used for 3,000 hours. So this is a break-even point.